20 minus negative 4 times 5 is negative 20. Two negatives make a positive, and that gives us 0. So no inverse. B is a singular matrix. It does not have a pair. How sad. Okay. And that is it for finding the inverse of a 2 by 2. We're going to do one more problem. Alright, so problem 5, there's going to be 2 parts, but how can you use matrix multiplication to encode the account number from a credit card? Okay, so we have this account number, so when you plug things in, this is to the best of my knowledge, when you plug things in when you buy something online, how it processes, it doesn't just like process it, because then people could hack and know all your credit card information, right? So there's like a coding process on here. So one way that we can encode the account number from a credit card is using a matrix. So first we need to choose a matrix. And it could be any matrix as long as this matrix has an inverse, okay? Because whatever we switch, we want to be able to switch it back. So we're going to say our coding matrix is, let's just do 2, -1, 3, and 5. Okay, and step 2 is we want to be able to multiply it. So we can't multiply a matrix, a 1 by 16 matrix by a 2 by 2. So we're going to have to make it a 2 by something matrix. So I'm just going to take these 8 numbers and put it underneath here. So to make an account matrix, which is going to be 4, 1, 7, 3, 1, 2, 3, 4, 9, 8, 7, 6, 1, 3, 5, 7. Okay. And now to code it, we can times this by this whole thing. So step 3 would be to do C times A. So we're going to do this 2, -1, 3, 5 times this long one, 4, 1, 7, 3, 1, 2, 3, 4, 9, 8, 7, 6, 1, 3, 5, 7. Okay, so a little bit complicated, but we should be able to do this. So row times column. 2 times 4 is 8. -1 times 9 is -9. So 8 minus 9 is -1. Okay, row times column. 2 times 1 is 2. -1 times 8 is -8. So we're going to get 2 minus 8, which is -6. Okay, 2 times 7 is 14. -1 times 7 is -7. 14 minus 7 is 7. 2 times 3 is 6. -1 times 6 is -6. So 6 minus 6 is 0. 2 times 1 is 2. -1 times -1 is -1. So 2 minus 1 is 1. So 2 times 2 is 4. And -1 times 3 is -3. So 4 minus 3 is 1. 2 times 3 is 6. Minus 5 is 1. 2 times 4 is 8. Minus 7 is 1. Okay, so a lot of 1s at the end there. And then we have to do it for the bottom. So 3 times 4 is 12. Plus 5 times 9 is 45. So 12 times 45 is 57. 3 times 1 is 3. 5 times 8 is 40. So 3 plus 40 is 43. 3 times 7 is 21. Plus 5 times 7 is 35. So we're going to get 56. Let me add those together. 3 times 3 is 9. 5 times 6 is 30. So 30 plus 9 is 39. 3 times 1 is 3. 5 times 1 is 5. So 3 plus 5 is 8. 3 times 2 is 6. 5 times 3 is 15. 6 plus 15 is 21. 3 times 3 is 9. And 5 times 5 is 25. So 9 plus 25 is 34. 3 times 4 is 12. 5 times 7 is 35. So 12 plus 35 is 47. Okay, so now this is what the system is actually going to process. It's going to send it over to get processed. And then once we have this though, they're going to go back. And B is saying, so this is our encoded message, okay? It's like our secret message. That means actually our credit card number. So now we're going to say, all right, how do you decode the matrix to recover the account number? Okay, so now to decode it, all we're going to do is we're going to say, all right, how you would decode it is you would take our matrix that's secret, our coding matrix that we didn't tell anyone, otherwise everyone would have it, 3, 5, and we're going to find the inverse of it, and then we're going to multiply it by what this one is. So -1, -6, 7, 0, 1, 1, 1, 1, and 57, 43, 56, 39, 8, 21, 34, and 47. And then once we do this inverse and we get this, we will get our account number of 41731234 987611357. So that's the concept of it. If you wanted to try it, we could multiply those out, find the inverse, multiply them out. And one way to find the inverse on your calculator is do second matrix. Go to edit, and I already edited it with this matrix. Oh, I did it with this one. So I'm going to change this 2 by 2 matrix to a 2, -1, 3, 5. Okay, second quit, second matrix, and I'm going to change this to a 2 by 8 matrix. So this is just something a little bit extra. And we're going to do 4, 1, 7, 3, 1, 2, 3, 4.